My name is Dele Ogunseyitan. I'm a professor and chair of public health here at UC Irvine. I thank you very much for coming tonight. We are expecting more people because of the RSVP that we received. So please bear with us as some people come in, and we'll direct them to the side aisles just to make sure they don't distract from the proceedings. I've been told to be very brief, and I will try my best, given the excitement that this topic has generated, to welcome you all to the Program in Public Health event, to UC Irvine, and to those who are coming from out of town to our Orange County. It is, in my view, very few things that a university, whether public or private, could do better than organize forums like this, where we share knowledge, where we give hope, where we explore the challenges that face our world. It reminded me to think about one of my favorite books written in the last century. This is a quotation from a fellow African. I think he adopted North Africa, really a Frenchman, Albert Camus. In his classic book, The Plague, he said, and indeed it could be said, that once the faintest stirrings of hope became possible, the dominion of plague was ended. He also said in the same book that there's nothing more for humans to learn from such experiences than to gain knowledge and the memories of the events that we have. Those memories of the past few weeks will haunt some of us for a very long time, but tonight we celebrate the concentration of knowledge at universities such as UC Irvine and the ability to bring people together to contemplate, to think about different perspectives, and to chart the way forward. This is what we do, and this is why we were concerned about the confusion that seemed to have plagued the country in the last few weeks, and we hoped that tonight's event will solve some of the questions you have and also help us move forward with hope. This event will not have been possible without the generous support of many deans across our campus, all the way from the provost's office. Several schools participated in financial support, but also moral support for putting together the occasion. We thank them. I'm not going to name them all, but they know who they are. But it's not just the money that they give. It's also the idea that when we face complex situations like this, we need to bring many, many disciplines together to help us explain and to help us reach for the deepest knowledge bases that we have to craft solutions to the problems. We were also very grateful for the support of those who are not listed on this slide, who wanted to provide other forms of support. And we'll be here all night if I were to list them all, but I really want to acknowledge them in generality. The person who had the idea that UC Irvine should do something is Dr. Andrew Noymer. He was supported in bringing all of the guest speakers together and advertising the presentations and the forum, and really taking his hat to all of the deans to collect for donations. He really made this happen in many ways, but also supported by many staff, some of whom are in the audience, some are also outside the building helping us find our way here. So I wanted to thank Andrew specifically for the initiative. He's been in the business of tracking and modeling infectious disease for a long time, beginning with his undergraduate degree in biology at Harvard, even though he calls himself now a social demographer, focuses primarily on health. And he's learned a lot of things about the flu epidemic that killed a lot of people in the early part of the century. Please join me now to welcome Andrew Noymer, who will introduce the panelists, guide the presentation tonight. Andrew.
Thank you, Deli, for that kind introduction. I'd like to thank you all for coming. This event wouldn't be possible without all of you here, and I'd like also to thank the sponsors, as Deli did. There is an audience also at the UCI Medical Center who's watching us over a video link, and I'd like to welcome you to the event. I'd like to remind everyone, please, to silence your mobile phones. And I'd also like to thank our 5 wonderful panelists who will be educating us tonight about everything that we need to know about Ebola. I chose for us a virologist, a disease ecologist, an epidemiologist and public health expert, a hospital infectious disease control officer, and a health economist. And I think you'll agree with me at the end of the night that these 5 perspectives together will give us a reasonably complete picture of this Ebola event as it's unfolding. And I hope this may be the first of several events that we have here at UCI as regards Ebola, as we learn more and hopefully as we can talk about the Ebola in the past tense. So I'll introduce the speakers one at a time. And our first speaker comes to us from right here at UCI. It's Mike Bookmeier. He's a professor of infectious diseases in the Department of Medicine and the Department of Molecular Biology and Biochemistry. He's a virologist by trade and the deputy director of the Pacific Southwest Regional Center for Excellence in Emerging Diseases. He's worked on emerging viral infections and viral protein function as well. He has a Ph.D. in virology from McMaster University, as well as a MS in public health from Washington State University. So with that, I'll give the podium to Mike.
Thank you for the invitation. It's rare, I think, first of all, that we have an Ebola epidemic that has stirred this much interest. And secondly, it's a bit like when you were a child and being brought out you know, when your parents had guests and they wanted you to sing and dance for them, to have your own family, the audience is even better. So it is a great pleasure to be here and to have a chance to talk a little bit about Ebola. Just to put this in perspective, I've actually worked on this infection, and I published my first paper in Journal of Infectious Disease in 1981. And it was a paper that defined the difference between Marburg and the 2 strains of Ebola. We knew of 3 strains at the time. And I can tell you that it was a very long time before anyone in the field got interested in these exotic viruses from faraway places. The problem in this field has always been generating interest. We have interest now. We need to run with it. We need to really follow up on it. And for me, I think the reward will be if we can actually get biotech, if we can get big pharma interested in producing either one of the 2 vaccines that have been sitting on the shelf for greater than 10 years now, that are 100% effective in primates, or any of the number of antiviral drugs that have been developed at USAMRIID by Department of Defense contracts and others. There are plenty of leads in this virus. I think we know how to control it. We've seen with our own patients, with the patients that have come back to the United States, we've seen that we have a good idea how to handle them clinically. The disease is devastating in a situation where you don't have adequate hospital care. But in a situation where you have adequate hospital care, where you can perform transfusions, where you can keep a patient hydrated, where you can dose them with heparin or with other anticoagulants, it's not a death sentence. And if you can add on the ability to use antiviral drugs in a case like this, I think it's a beatable disease. So I think the pessimism that we're seeing is fear. And Albert Camus was absolutely right. Fear is the worst enemy. There's a reason that we called this bioterrorism, because the threat of the disease was more terrifying than the existence of the disease. And so when we began to think about the effect of these, the impact of these infections, when we talked about terrorism, this is what we were talking about. So I'm going to give you a few minutes of basics about Ebola. I'm not going to pretend to cover the whole field because we have 4 expert panelists after me and plenty of time for discussion. But this is a, I'm not sure how to use a pointer up here since there are screens, but what I'm going to say is that the image here is a classic image of Ebola. In fact, this image is even being produced as a stuffed toy. There is a company that actually sells models of viruses that are in the form of a stuffed toy, and you can buy these at conferences. You can probably buy them, in a number of swap meets around as well. And this is the image which was taken actually by Fred Murphy back in 1976 at the CDC, which is being used as the model for that stuffed toy. So it isn't all, Ebola can be warm and fuzzy. When we think about these diseases, there are 2 viruses that really are closely related, and we have to consider both of these, Marburg and Ebola. They're both hemorrhagic fever viruses. Marburg first arose in 1967 when kidneys were exported from Uganda to produce polio vaccines, and they were sent to Marburg, Germany, and to Czechoslovakia, and there were outbreaks simultaneously in both of those labs of a disease that resulted in fatalities in a number of laboratory workers. And that was called Marburg hemorrhagic fever. So that was the first indication that we had that these viruses exist. Ebola virus was discovered somewhat later in 1976 with almost simultaneous epidemics in 2 different locations, one in Mayenga in Zaire on the Ebola River, and the other in Sudan in a desert situation. So 2 very different locations. These data suggested that there were 3 different variants of these filoviruses, and one would be Marburg, Ebola Zaire, and Ebola Sudan. And that basic structure has held up. That's basically what we published in 1981, and it has held up with the addition of some additional strains that have been added in. If we think about Ebola virus, how is the virus transmitted? It's transmitted by contact. Is it a respiratory virus like influenza? Could I cough here up on the podium and infect all of you? No. It's a virus that spreads by contact with bodily fluids, contact with blood. It could conceivably spread by cough, which would be a droplet infection, but the range of those droplets is only about 6 feet. So that if you're standing more than 6 feet away, you're perfectly safe. So when we think about this, think about the details of someone going on the subway from Brooklyn into Manhattan or Brooklyn to Harlem, like this young doctor did when he got back from Doctors Without Borders. The exposure is much more limited than we make it out to be, but because we don't know, we have to err on the side of caution. And so that's understandable. The distribution of the virus is endemic in bats. It's enzootic in bats. It's a zoonosis, an infection of animals that occasionally spreads to humans. And the interesting thing about bats is they can carry this virus. Now that again is a familiar theme in virology. Most of the dangerous viruses that we deal with are enzootic viruses that emerge suddenly into a human population. If you take the 1918 flu, this is a virus of waterfowl which spread to pigs, which spread to humans. So these are zoonotic infections that spread eventually into humans. In humans, they can thrive. But because they're new in humans, they adapt. And so one of the effects that you see in these viruses is a tremendous amount of mutation early in the infection cycle and throughout the course of this epidemic. There was a wonderful paper that was just published in Science and an article about it in the New Yorker last week about work that's being done by Pardis Sabeti at the Broad Institute at Harvard, looking at the mutations that are occurring in this virus in real time. I'm going to come back with one slide on that at the end. We have a number of people that are at risk, monkey handlers, for example, healthcare workers, we've seen that. And antiviral drugs and vaccines that are available for human use right now are none. So what you see is scrambling, trying to adapt these to try to get a foothold on this market. Some of this is really shameless commercialism. If you have a drug that maybe people said was marginal and you have an opportunity to try it out and score some points for your company, there is a temptation to do that. So that I think you have to watch out for. I'm not going to spend a lot of time on this because I've already said most of what's on this slide. But the virus is a highly contagious or highly fatal virus. With Marburg, more like 25% mortality. With Ebola, 50% and up, depending a lot on how the people get care. When the disease occurs in remote villages, it can easily be contained because you can circle a village and you can prevent spread from one village to another by blocking transport from one village to another. So the epidemics will burn out. But what we've seen is we've seen a change in the demographics of disease with urbanization. When the infection got into Conakry, Guinea, a city of 1 million people, it spread like wildfire in Conakry because there is no private space in a city like that. You know, people are in close contact, and there is no way to regulate that. So you have to understand that the surroundings are adding to the hazard, to the spread. And so if you can isolate those patients, it is perfectly feasible to stop the epidemic. Doctors Without Borders, is constructing their Ebola wards away from the city, in the middle of a field or on the top of a hill, away from traffic. And by doing that, they're isolating these patients away from the general circulation. And by doing that, they're blocking spread of infection. So community engagement is important. Getting people to go along with the program, educating people so that they don't think Ebola is a plot or that Ebola is magic spirits. There are still people that believe this. I think you all probably saw the story about the healthcare workers who were murdered in a Ghanaian town when they came in to try to educate people about Ebola. This is a good example of the level of fear and misunderstanding that really exists. So Ebola is a member of the Filoviridi. There are a couple of other genera, the Quavo viruses and the Budibongo viruses, and there are a number of others that are not virulent. So this tells us that the replication of these viruses in humans is not always the same fatal outcome. These are viruses, the Reston virus, for example, is a virus that the Hot Zone, the book The Hot Zone was written about the Reston virus. And it was an outbreak of a virus disease that killed basically a whole colony of monkeys in Reston, Virginia, but it was found to be non-pathogenic for humans. Few humans seroconverted, but there were no human deaths. So how can that be? How can you have a virus in its natural setting in Africa, which is virulent, and a virus in Reston, Virginia, which is not? Well, it's a different virus. It's a different strain of virus that comes from a different origin. And this was imported with laboratory monkeys that were housed in the Philippines and had come from Southeast Asia. What is common between Southeast Asia and Africa? And if we think about the enzootic host, the natural host of Ebola, wasn't known for many, many, many years. It's only in the past 5 years that we've really begun to understand it. Well, it's fruit bats. And fruit bats, like waterfowl, can fly. So they can go from place to place to place and spread this infection. They don't show signs of disease, but they do leave their excreta on fruit. They are eaten in many places in Guinea and West Africa, are eaten as a source of protein. There is evidence now that's surfacing that suggests that the index case, in fact, was a little boy whose family prepared fruit bats for consumption, and that he may have caught the Ebola infection from that fruit bat. All of this is going to come to light, but it's going to take time. This is the epidemic now. This is very different from the picture that had evolved over the previous 30 years of Ebola epidemics. These were scattered throughout Central and West Africa. The closest that we had to this West African area was in Togo, which is immediately adjacent to Sierra Leone and Liberia. We've seen a little bit of spread into Nigeria, and so you see the infection is beginning to spread around Guinea, Sierra Leone, and Liberia. But this is clearly the hotbed, the hot zone in terms of these infections. And controlling that infection is absolutely essential at this point. We've seen now Nigeria has been declared virus-free. Senegal is virus-free. Mali has just had their first cases this week. Now we have virus in New York. We've had virus in Dallas, Texas. Should we take all of this as an example of a virus that's going to spread around the world? No, absolutely not. Number one, we don't have the natural host here. So the chance of establishing this virus in this ecosystem is impossible at this point, unless you switch natural hosts, which is unlikely to happen. And the second thing is that with first-class medical care, we can isolate people, we can treat them appropriately, and we can block that infection. The structure of these viruses, and I know this is a mixed audience. The structure of these viruses is very similar. This is Ebola, this is Marburg, and the only important point I think to make here is the size of the genome, about 19,000 base pairs, so just short of 20,000. Why is that number important? Because RNA viruses replicate very rapidly, and they generate mutations in about 1 in every 10,000 replication cycles. So for each replication of this 19,000 nucleotide RNA, you would expect at least 2 mutations introduced. Multiply that times the enormous numbers of virus particles that you find in tissue, and that's a lot of mutations. And so it sets the stage for very rapid mutation away from viral drugs or an adaptation into a new host or whatever. And the second thing is that in Ebola, there is an interesting editing phase that occurs that allows the virus to produce 2 different types of glycoprotein, one of which is fixed in the virus surface, so it looks like this, and the other which is free-floating in the solution. And it's so-called soluble glycoprotein. We think that has something to do with the pathogenesis. We don't know for sure. These proteins, VP30 and VP24, are important, and that's because they're inhibitors of the immune response. So this is a virus that fights back. I'm going to go quickly to that part of the talk. This is just the replication, virus coming out of cells in these long strands, and here virus inside the cell getting ready to be assembled at the surface. These extrude out through the surface and pick up a membrane on their way out. So this is the internal core of the virus here, and this is when it comes out. You see it has the core wrapped in a lipoprotein envelope. The symptoms of Ebola, I think I'm going to leave this to George, because George is really here for the clinical aspects of this. But basically, you've heard these described in the literature. But as far as Ebola virus pathogenesis goes, this is important. Pathogenesis is the way that a virus causes disease. This particular virus attacks the most essential units in the immune system, and that is the phagocytic cells that are the first responders. So it's as if this virus came in and destroyed all the firemen and policemen in Irvine and then began running rampant through the city. What happens here is that you're destroying the cells that would respond appropriately, that would generate the innate immune response, the interferon response, and then would proceed to prime the adaptive immune response. And the proteins that do this are VP24 and VP35 that inhibit that innate immune response. This is not uncommon in viruses. Many viruses have an anti-immune response component, and these viruses certainly do. So VP24 affects nuclear translocation, and VP35 affects RIG-I, 2 components of the interferon response. The S-glycoprotein may interfere with neutralizing antibody activity. So transmission of Ebola, again, I'm going to leave this to our other colleagues. And just say that these are zoonotic infections. The natural hosts are fruit bats. Infection of other species, including human and primates, occurs. And when bats are consumed, they can spread to humans. And keep in mind that we're not the only ones who are affected by this. The population of lowland gorillas has been devastated in West Africa because of Ebola virus infection. So I'm going to stop there.
Thank you, Mike. That was very informative. I learned a lot about the virus. Jamie, our next speaker is James Holland Jones from Stanford University. I have it later. Okay. James Holland Jones is an associate professor of anthropology and a senior fellow at the Woods Institute for the Environment at Stanford University. Jamie is a biological anthropologist with wide interests in biodemography, life history theory, and human ecology of infectious disease. And so Jamie has done a lot of work on a number of different viral and bacterial diseases. And today he's going to tell us about not the virology, but the ecology of Ebola virus. And you'll know a lot more about what disease ecology is, I'm sure, after you hear Jamie speak.
All right. Thank you. Well, thanks for having me down. An exciting event. Got 15 minutes. You're going to give me like a... I never use notes, and so that's why I forgot them over there. So I'm just going to start a timer, too. And there we go. All right. So I'm supposed to talk about Ebola ecology. I am an ecologist. I'm a biological anthropologist. I worked on primate ecology for my PhD work, but I've become more of a social scientist. Some acknowledgements, very collaborative, everything I've done. I don't have time to go through them all. But I just want to put on my social scientist hat for a second and put up this very provocative cartoon by the Portuguese cartoonist André Carrillo. And just to highlight, to remind myself to note that this current epidemic of Ebola is very much a social and political phenomenon. We're going to hear some more, I hope, about the social and political phenomena. We've already alluded to them with this idea of this panic driving the day. And you'll see that the politics are not unrelated to the ecology. We'll get to that. So Ebola is a social phenomenon. The current focus of the disease, as heard, is in West Africa here. So this is this is the country of Guinea here, and Sierra Leone and Liberia. The index case has been traced back to this spot in Guinea in the beginning of December of 2013. And you'll notice that this is right near the three-country border, right? This is a very active area with lots of porous borders going across the three countries. So here we have the index case. The very first case is 2-year-old boy in Gekadu, Guinea. We have Guinea, Sierra Leone, and Liberia. Some work that I've been doing with my colleague in political science at Stanford, Simon Jackman, we've been trying to understand the dynamics of the disease. And when we say dynamics, we mean the sort of how the disease changes over time using mathematical models and some statistical approaches. And just to show you some of what's going on, this isn't what I'm supposed to do, but this is part of the ecology, right? This is the population ecology. In Guinea and Liberia and Sierra Leone, we have fairly distinct epidemics. This is just WHO reporting data, and it happens at irregular intervals, particularly early in the epidemic. And so that's why there are big gaps in between there. This is just whenever WHO releases data, and you can see it's growing disturbingly. What we have here is a plot of it's called the effective reproduction number. It's essentially the number of secondary cases that a single case produces. So I have Ebola, I infect how many people? I infect R sub I individuals on a given date, okay? And you'll see that this is for Guinea. Early on, we're coming close to 2. The average case would infect 2 people. And we're down to about 1.5-ish, and it's remained very constant at 1.5. Well, we need to get that below 1, right? Because this is a growth rate. If you get it below 1, it means that you're actually declining, right? You're not growing by generation of infection. We've fit some models. Our estimates say that without intervention, they're consistent with the things that we've heard from CDC and WHO. Without intervention, this curve will continue to grow, and it'll eventually plateau out somewhere up here, and it'll be about 1.4 or 1.5 million cases. that's in the absence of intervention. Okay. Okay, so we've just learned Ebola is a filovirus. There are the two major clades. We call a clade a sort of group of organisms that are more closely related to each other than they are to anything else. I don't need to go through that. We have the Ebola Zaire down here is part of this broader evolutionary tree of the filoviruses. I'm going to skip over that. Okay, so the current outbreak is monophyletic, which means that it has a single origin. They're all descended from a single case to the best of our knowledge. And the important thing for this with respect to the ecology is it means that there isn't a continual passing back and forth between whatever the reservoir species is and humans. And this is characteristic of Ebola outbreaks. It gets into the human population. It then spreads outward from human to human contact. And this actually gives us a clue about the reservoir ecology more broadly. So the red here is our current epidemic. These are previous Ebola Zaire cases. We can use the molecular information to come up with some dates of when the introduction happened, and we can see that this is essentially a distribution of possible dates that are the higher the curve is, the more probable it is. And this is for the introduction into Guinea, this darker green curve, and we can see that it's somewhere in mid-February. And we actually expect it to happen after the actual introduction, because this is when there's a random loss of these different viral strains, and so this is called the coalescent point. It happens after the actual introduction. So this is good. This tells us that we once again, we have this single introduction as far as we can tell. And then we have an introduction into Sierra Leone, and we have a date, we can date that, and that sort of thing. It's a little pet peeve of mine, that will the virus mutate? You hear this in the media all the time. I've heard it on NPR, I've seen it in the New York Times, and people say, will it mutate? Well, yes, it will mutate. It's a virus. In fact, every time it replicates, it's going to have two of them, right? So the simple answer is yes. What we need to be concerned about is whether or not selection will be working on this and how we are affecting selection, because adaptations are produced by selection. And here, at the time that Pardis Sabeti and her team wrote this paper on the 28th of August, there were 50 unique mutations and there were 30 unique lineages of this disease. It's diversifying, and this is the stuff of natural selection. We then go in and we impose selection on it, and that's where these novel viruses are going to come from the types of selective pressures put on them. Okay, I'm supposed to talk about reservoir ecology. So what are the properties of a reservoir? A reservoir is where the disease lives when it's not killing people, right? So this is a disease that is highly fatal to humans. It's extremely disruptive. It doesn't live in a human population. It's a classic zoonosis. It lives in some animal, presumably, population in the wild, and it comes into contact with humans. It spills over, is what we call that, and then it gets transmitted through the human population. It's probably a mammal, right? This is what we know about the reservoir. It's probably a mammal. We have a variety of reasons for thinking this. Among them is the fact that once it gets into humans, it can be transmitted, right? It has adaptations to our physiological machinery. We know that lots of other mammals get infected with it. Primates, of course, and bats and rodents and pigs, some antelope. So it's probably a mammal. It's sufficiently widespread to account for all the spillover events. This means that it has to span at least the Congo Basin and now well into West Africa. It actually has to go into some pretty xeric habitats, some pretty dry places like Sudan, and it actually has to go down into Angola and down getting towards Mozambique. This is a widespread place if we look at all the outbreaks that have happened of Ebola and Marburg. There has to be sufficiently low mortality in the reservoir population that it doesn't just wipe out that population as well. It has to be able to persist in the wild somewhere. And there has to be a plausible mechanism for occasional spillover. There has to be a way for humans to come in contact with this species, and that happens reasonably regularly, right? We've had 25 plus or minus outbreaks of Ebola. And so this happens on a fairly regular basis, but it can't be so ubiquitous that it would happen all the time. We can think of this as the Goldilocks principle. Right? It has to be not too hot, not too cold. It has to be something that people occasionally interact with, but not too often that it would be ubiquitous. Piggott et al. Very recently have this really remarkable sort of geographic tour de force of a paper in which they lay out a probability of where the reservoir likely lives. It has to, as I said, it has to span the Congo Basin, and of course it has to come out into the far western coast of Africa here as well. It has to go into Sudan, has to stretch down into Angola and over towards Zambia, Mozambique. What could this be? The big, there are two classes of organisms that we think of as being most likely as the reservoirs. And right now, the jury is still out, but we tend to think it's fruit bats, and there are a variety of reasons for that. These are hammer-headed fruit bats, a widely distributed species in Africa. But the other possibility is rodents, and this is a cane rat or a grass cutter, as they're called in the region. And cane rats are eaten with great gusto, right? This is good eating, and these are all hunted cane rats here. This one has been dried and smoked and ready for consumption, put in a stew or something. The thing about cane rats is that they're approaching commensal. They have a very close relationship with people, and they seem to violate the Goldilocks. So we're looking at bats, and so there are three species in particular. There's Francaise epauletted bat. There is trying to call particular English. Where did I put it? This is what I don't use notes. Oh, here we go. It's right. It's the little collared fruit bat, and then of course we have these crazy-looking guys, hammer-headed fruit bat. Okay, and these are large-bodied bats. You know, they're a kilogram or two. They're big. They have a four-foot wingspan or so. They're not like the giant flying foxes of Asia, but they're pretty big, and they're reasonably good eating. Right? And they fly in enormous aggregations that make it very worthwhile to hunt them because they roost in trees. They're daytime roosters, right? So they go and they rest in the trees during the day. They feed at night. They're pretty easy hunting, right? That you have trees full of them. You have a shotgun. You've got dinner. And more importantly, you've got meat that you can sell at the market. Okay, and these three, they fit the distribution pretty well. Okay, so these are the distributions of these three bats. How does it happen? They're smoked, they're sold in market, right? That's the sort of obvious way by which bats could lead to spillover into humans. But there are other ways as well. Bats are messy eaters. You know, monkeys get a bad rap for this, but bats are just as bad. They eat this fruit and they drop it. And this fruit fall is then picked up by other animals in the forest, including duikers, which are forest antelope, including pigs, particularly Red River hogs, including primates, including people, okay? And so if they're excreting virus in their saliva, that's a possible route of transmission. Another neglected route of transmission is bat guano. If they're excreting in their feces, there does seem to be a thin, these are small sample sizes, but there is an epidemiological link between Marburg and Ebola outbreaks and mining, right? And so bats often will aggregate their guano in these caves where people can have contact with it. And then the other indirect route is through hunting of things like duiker or pig or monkeys that have been infected by eating the fruit fall from these messy. Okay, so there are multiple routes of possible transmission here from bats into people. Bats are extremely adaptable, and they live around and inside human habitation quite well. Thank you very much. This is a picture I took out of my window in downtown Kigali, the capital of Rwanda, and you can't really see it very well, but there's an enormous colony of free-tailed bats here. So there are probably 100 animals in that circle there. They're just fine with human habitation, okay? And this is part of the important story here about what are we doing? This is one of the questions Andrew asked me. What are we doing that might be making this more likely? Well, one of the things we're doing is we're cutting down primary forest. Guinea is 26% forest cover based on satellite imagery, but less than 1% of that is still primary forest that hasn't been cut and regrown, okay? And secondary forest has a very different structure. So if we were to look down at a satellite, this is an oil palm plantation in Malaysia, and Indonesia in particular, which is the second biggest oil palm producer in the world, has recently been trying to crack down a little bit on deforestation. We'll see how that goes. And a number of international companies have moved their operations or have expressed interest in moving their operations to Africa, where, of course, the oil palm is actually native, right? And so putting big plantations in here. The bats love this. They love the palm fruits, and they will come and they will eat the palm fruit, right? They will eat mangoes and papayas. That picture that I showed you of the hammer-headed bats is from a papaya tree, if you know your horticulture. By cutting down primary forest, these guys have got to roost somewhere, and if they're not going to roost in primary forest away from human habitation, they'll happily do it in the mixed forest that's around plantations, farms, and cities. So through the land use change in West Africa, we're probably forcing the hand of spillover a little bit here. I want to sound, I'm at 60 minutes. Just very quickly, a little word of caution. We have not actually ever recovered virus from a fruit bat. They test positive for antibodies, right? So they've had an infection. We can recover some nucleic acids from their livers and spleens, but we've never actually gotten the smoking gun of the virus there. And I worry that we're going to say it's totally bats. We just know it. So let's go after the bats now. And so this is a vampire bat. In 1932, it was demonstrated that vampire bats were able to transmit rabies to other mammals. It was heretical at the time, but it was a major advance for science. And if we had said, okay, we figured that out, it's bats, we would have missed out on an important part of rabies ecology, that we have a variety of different hosts that can serve as reservoirs that tend to amplify each other's infections, skunks and raccoons, everybody, I've got rabies, red foxes, and even a frothing coyote here. So if we were to stop our investigations of the reservoir ecology because we knew that vampire bats were the ultimate reservoir, then we would have missed out a lot on the complexity of this disease system. And I suspect, this is a data poor statement. I suspect that we have a very complex and rich multi-host reservoir ecology driving Ebola. So I'll stop there.
Thanks, Jamie. That was great. And I'd like to compliment you on your use of R sub T and not R naught, because you mentioned that mutation is one of your pet peeves. And as some of my students are in the audience, they know that one of my mutations is calling everything R naught. So our next speaker is George Rutherford from UCSF, and George is the Salvatore Pablo Lucia Professor of Epidemiology, Preventive Medicine, Pediatrics, and History, and head of the Division of Infectious Disease Epidemiology, and vice chair of the Department of Epidemiology and Biostatistics at UC San Francisco. I don't know how you have time to do all that, George. George is an infectious disease physician and an epidemiologist. He's worked with the WHO, the former state epidemiologist of California, and he's worked with on so many different diseases in so many different settings. He's really an expert on everything in infectious disease, and he received his MD from Duke University and his undergraduate from Stanford, I believe. And he's going to tell us about epidemiology and control in West Africa. So thank you very much.
Andrew didn't mention that I was on his dissertation committee. It's great to be here. Actually, I've been to the Keck Center several times here, but I've never really been on campus. It's gorgeous. So I was asked to talk a little bit about transmission in West Africa, the current epidemiology in West Africa. You've heard some of this already. As we know, Ebola virus outbreaks have been widely spread in Africa, and I think Jamie's point about it being in the Congo Basin and the forest of West Africa are well taken. The transmission, you've heard all this, the likely transmissions from bats. I completely agree with you. When we don't know what's going on in infectious disease epidemiology, it's always the bats, right? Always. SARS, it's the bats. Well, it's the bats. And there's actually a whole school of thought that this might be reptiles. The bats get it from. So, and the other thing I should just say, just to expand on this, but as a former state epidemiologist, there are no raccoons in the West with rabies. That's a phenomenon of the East Coast. Yeah, okay. So just don't go kill all the raccoons in your bed. All right. There's a secondary transmission, as we've heard, from either percutaneously or for mucous membrane contact with blood or body fluids. How do you get stuff in on your hands if your skin? Because you have little breaks and nicks in them, and it can get in there. There's no evidence of droplet or airborne transmission. The one thing that wasn't touched on, but this was a huge amplifier in this outbreak, was that preparing bodies for burial, for traditional burials where the bodies are washed, also seemed to be a huge amplifier. There was at least one case where a traditional healer was prepared for burial, and there were 14 secondary cases. So the people at highest risk are healthcare workers and close family contacts. Importantly, this is the most important thing I'm going to say, that transmission is from symptomatic people. Okay? You're driving around on the subway and you have no symptoms, you're not infectious. Now, if you had a blood transfusion from, okay, something like that, but it'd have to be an extreme, or you got an organ from them, it would have to be extreme. And it has to do with the levels of virus building up in the blood. And fortunately, this is the silver lining, that people with this disease do not really become infectious until they're symptomatic. And we talked about this. This is one of the WHO things. They quickly blame the bats for everything as well. But the point is that it only spreads when people are sick. And this is yet another WHO factoid about how you can't get it. All fair. Now, not getting it from eating uncooked bats, okay, maybe. You can't. There are no absolutes in this. You heard from Michael a little bit about the vaccine availability. Interestingly, especially in the Congo, there seems to be some background levels of immunity to this, with the thought that people may have had low levels of low inocula virus, taking care of family members and stuff, and recovered. They have had some sort of disease, but recovered. And that sort of opens up a whole interesting possibility. Could you screen people and this is in the Congo, not in West Africa, but as this epidemic goes on, there's probably going to build up, if this is true, you'll build up a fairly substantial body of people who are immune, who have antibodies to. You could use them as people to provide the care. So it's an interesting thought that's kind of kicking around. The focus is on preventing transmission in communities and healthcare facilities, seeking care, making the diagnosis. You have to make the diagnosis. This is a place where malaria is totally endemic. What's happening now is that kids aren't getting treated for malaria because they're febrile and they come in, they get put over in a corner, you go through all the Ebola magic of trying to figure out if they're antigenic Ebola, and their malaria is not getting, which is a real mess, not to mention their typhoid. And then then there are barrier precautions, and we'll talk about that, isolation, and then there's other issues around safe burial practices. Important thing you heard about R sub naught or sub T, give you that one. And this is what it looks over here. I'm looking at this thing that's circled. If you're hospitalized and they're doing it right, about 1 in 8 healthcare workers will be relatively right. For every 8 cases, 1 healthcare worker will be infected. If you're doing it right at home, for every, say, 6 cases, there'll be 1 family member infected. If you're not doing it right at home, which is largely what's going on now, you'll have 1.8 infections for every 1 case. So the whole premium here is to move from here to here, get people into isolation. And this is why we're building, 17 100-bed Ebola treatment units in these countries, because there's a huge premium on getting people into care. At the end of the day, there's still not going to be enough, and there are these sort of smaller clinics that they're using. And I really basically waiting to see how that plays. So the basic infection control, this is from the WHO's manual about how to treat viral hemorrhagic fevers, which there are several different types in Africa, and they go beyond the filovirus. Basically trying to identify, isolate patients, protective clothing, disinfection of non-disposable supplies like the boots that people wear, safe waste disposal, and this was a huge issue in Atlanta. The person who handled the waste for Emory Hospital wouldn't take it away. They had 3 containers worth, tractor containers worth of waste which had to be burned before anybody would take it away. And then again, cremating bodies and not washing them. What's really happening now, because cremation is so culturally averse in this area, that people are they get heavily disinfected with bleach and then buried in shrouds. The business I think this is a really revealing comment. This is from a recent editorial in the New England Journal of Medicine that was written by a nurse who was actually one of the people doing humanitarian aid there. PPE is personal protective equipment. This is the suit they all wear. No one should wear the PPE for longer than 40 minutes. It's unbearable for any longer than that, but it's easy to lose track of time. We have to monitor our colleagues. The process starts in the dressing room where getting into the PPE takes about 5 minutes. We have a designated dresser, kind of like actor, responsible solely for making sure that we are wearing our equipment properly and not a square millimeter of skin is exposed. In case 1 layer is accidentally perforated, we wear 2 pairs of gloves. Most people are now wearing 3, by the way. 2 masks and a heavy apron on top of our full body overalls. When we exit the isolation area, we're sprayed down with chlorine solution and peel off the PPE layer by layer. Some of the equipment, goggles, aprons, boots, thick gloves, can be sterilized and used again. Everything else, overalls, masks, head cover, burned. There's a huge problem with heat illness in healthcare workers in these countries. So they have to rotate because they're so hot. This stuff is so constrictive because you don't want it, it's impermeable, right? It doesn't do you any good to have an air conditioning going through you. They've really had to shorten the times that people are doing it. So the current outbreak, as you heard, with the first case in Guinea, in a 2-year-old with rapid spread to Conakry, capital, and to Liberia and Sierra Leone. I will point out, everybody says Guinea like everybody knows exactly where that is. There are actually 4 countries with the name Guinea in it. So they're right next door. This guy, oops, I got it on the next slide. Right next door is Guinea-Bissau, and Bissau is just the name of the capital. This was the Portuguese Guinea. There's Equatorial Guinea, which is down in the Gulf of Bight of Benin, in the sort of armpit of Africa. It goes down, and it's the only country in Africa where people speak Spanish. I tell this to my students all the time. They want to do global health, and they're learning Spanish. I said, okay, here's the story. There's 1 country. And then there's Papua New Guinea, too. So so I just want to point out, this was the former French Guinea. That's why the French are sort of mixed up. Well, it started here in this town of Guécadou. That was the market town, and then spread across into these borders. Currently, this was as of last Saturday, there have been about 10,000 cases. The thought is that there are only about 40% of the cases are reported. So you can multiply this by about 2.5, come up with the right number. There have been additional cases in other parts of the world. In Nigeria, there were 18 cases with 3 generations of transmission from somebody who had the money to get out of, I think it was Liberia, and go to Lagos for care. There have been 8 cases in Europe. There was 7 were in evacuees, and 1 was a nosocomial. Nosocomial means in the hospital. Nosocomial transmission to a nurse in Madrid. In the U.S., we've had 9 cases, 5 in evacuees, people who are pulled out. 2 in travelers, I'll call them, the guy in Dallas and the doctor in New York, and then 2 secondary nosocomial transmissions to nurses in Dallas. In Senegal, there was a single case in a traveler who made it to Dakar, which is kind of, oops, in that map, it's sort of up and around the corner. And then there's been a single case in a child in Mali, which is the country sort of right behind all these. But overall, you can see that these countries have been variously affected, and the case fatality rate is about 50%. Right? So you've seen this slide already. This is where it's most active right now, and Mali is back here. It's this guy back here. So Côte d'Ivoire is a great big population center in Abidjan. That's a concern. Here in Senegal, that's up here, there's a large population center in Dakar. So that's of concern as well. You look at the epidemic curves, which you saw already. This is a little bit earlier in this year, but you can see these rapid rises in Liberia and Sierra Leone. Interestingly, when this happened, this little plateau here that was happening in Guinea was interpreted favorably, that something was actually stopping. What it was people were keeping their relatives out of hospitals, afraid to go. And this shows you what happened in Nigeria. From a single case that came in, there was these different waves of transmission, eventually ending up with 3 generations of spread. Lagos is arguably the largest city in Africa. So keeping it under control there, it was a huge, big deal. Again, how many patients are there outside of West Africa? I went through the numbers for you. In the United States, we've had 9 cases, 5 in people who were brought here specifically, 2 in travelers, and 2 in 2 domestic transmissions. So those 5 have recovered, 3 are in treatment. You heard this already, that this represents a single introduction with human-to-human spread. So that's sort of the basic epidemiology. Now, I'm going to talk about West Africa. Afterwards, I'm happy to Shriti to answer. I'm delighted to do this. We'll get up and answer all the questions about what the U.S. is doing. But just to talk about West Africa, how do you contain Ebola? You contain it by diagnosing people and isolating. And if you find out people have been contacts of those people, and especially people who might have been in very close contact, so we're talking about people who slept in the same bed, people who ate from the same, it's really close contact. It's not like, looking at you across the audience. Close contact. You'd remember. That they get quarantined. Now, this is an important distinction because these words are used interchangeably and they're not interchangeable. Quarantine, which is from the Latin quarantus, meaning 40. The reason it's 40 is because that was how long the Venetians' government made ships coming from Constantinople lay at anchor before they let them offload stuff. It's twice the incubation period of plague. So there's a reason for this. It means people who have been exposed but not yet infectious. This was heavily used in SARS in Beijing, where they quarantined maybe as many as 20,000 people. They put up big circus tents outside. Isolation, on the other hand, are people who are infectious, right? Who can transmit the virus, and whatever the organism is. You bring them in, and you put them in these isolation units so they don't transmit the virus to anyone. Quarantine are for people who are exposed, not yet infectious. Isolation for people who are sick and infectious. And sick and infectious are synonymous with Ebola. There is then this whole other layer of stuff that goes on besides the individuals. So you have to provide supportive care for patients, or else nobody's going to bring their relatives in. You isolate contacts as they become febrile. And so you hear a lot of, in the US about taking your temperature twice a day and, you know, da-da-da-da. That's the early sign. Fever is the first sign. And there's all this social mobilization that needs to go on, basically to prevent people from trying to bleed across the borders into the other countries, try and keep them in a place where they can actually get care, bring their relatives in, and, you know, basically continue to have society function. There are the preventive interventions, as I said, focus on meticulous infection control in healthcare settings. A medical audience will ask if respiratory isolation is necessary. The answer is no. However, in the great universe of cognitive dissonance, CDC has now said, well, you should probably do it anyway. And the reason is that respiratory, when you put somebody, a healthcare worker, puts the stuff on for respiratory precaution, they're able to, that takes a lot longer. So it's not sort of one of the things where if somebody starts to vomit blood or cough or create these huge aerosols from being intubated, or these are intensive care. You don't want to run out and put it on. You want to have it on when that stuff's happening. So that's the reason. The other reason is the Emory experience was if you wore the regular stuff, the glasses fogged up all the time. And with these positive, PAPRs, personal air purifying respirators, the face shield stays clear. So there's sort of practical reasons for this, but it's not because there's respiratory. Okay? Changing funeral practices and avoid bushmeat. You saw the bushmeat market, and contact with bats. This is what an Ebola treatment unit looks like in Guinea. So what are the responses? So the responses have focused largely around getting enough care so that people can be isolated and cared for. And with an emphasis both on isolation and on clinical care. There are Ebola treatment units with up to 100 beds, and the U.S. Department of Defense is building, this is like the construction brigades, are building these right now. The British government has kicked in a few, Médecins Sans Frontières, we say MSF. They've also put up several of these. This is something that's kind of ongoing. Now, kind of controversially, even at the height of even if when all this stuff gets built, and if it gets staffed, which is another issue, it's not going to be enough. And so then the questions are, well, what do you do with everybody else who's sick? Well, you have two choices. One is you can bring them into home, and again, give these sort of home isolation kits, which is what MSF has been doing, which probably really don't work very well. Or you could set up these sort of smaller isolation units, which are called Ebola care units, that have 8 to 10 beds, but really don't have ICU capacity. So for instance, they're not starting IVs. So it's oral rehydration, which, this is not, this is a real experiment going on, not called that. So it's tough. What are you going to do with everybody else? The huge, overwhelming need is for healthcare work. And we are, our chancellor at UCSF sent out a policy statement last week that said, you're welcome to go. We're not going to let any trainees go. If you go, you're on good luck. Your insurance doesn't work. Kind of keeps. But for the faculty and for the staff, especially the nursing staff, you say, this is an important humanitarian mission. You want to do this. You have our full support. We've set up an emergency vacation leave donation program so that people continue to be paid. We obviously work very closely with the city health department and the state health department about what we do with people when they come back. Touchy issue over the weekend. But we think that this is part of our mission. We're out pushing on this. But we also spend probably 5 times as much time worrying about what we do if somebody walks through the CDC has opened a healthcare worker training facility in Anniston, Alabama. We've sent several people there, 3-day hands-on training. And for anybody who's a medical student or a resident here, while people don't like having medical students and residents running around in the Ebola treatment units, they do want them in Anniston to run the simulation. really is an opportunity to go out and get your hands dirty, but sort of simulated way. And then, as I said earlier, there is this background of immunity, and it's, what do you do with these? Once people have recovered, they really are. They're the perfect healthcare workers. They're bulletproof, presumably. So the projections, as you heard, are that there'll be 20,000 cumulative cases. This is WHO's 20,000 cumulative cases by early November, which is probably about right. CDC has a best case and worst case scenario, and it's the worst case scenario that you always hear, which is the 1.4 million cumulative cases by the 20th of January. Now, in the various simulations that have been run, the tipping point is if you can get 70% of people into isolation. That includes both these Ebola treatment units and the Ebola care unit. So that's the tipping point. That's what everyone is aiming. And if you can do that, you'll start to see a decline in cases. It's just a little more. We can skip that. So what can you do? Assure your hospital's prepared. I know Shrudi's been working on this probably day and night. In Africa, there's a desperate need for healthcare workers. So if you're in clinical practice and you want to take some time off and go do something really worthwhile, we're talking like 3,000 people. There's also needs for disposable equipment and personal protective equipment, but that's really going to kind of come from government. There's some mass purchasing. We've been talking with the UC system-wide people in Oakland about maybe, or through the UCSF procurement office, about discounting. Maybe that's something we can help with. And I think not to be underestimated is the economy of these countries. And they're not people to harvest the crops, and they're going to have serious, serious food shortage. So that's something else that has to be. The voluntary organizations have been huge in this. Médecins Sans Frontières, International Medical Corps, Partners in Health, a whole bunch of different things. The Cubans have sent, several hundred doctors and nurses, which they do all the time. So that's really good. And it's, that's the big things. That's what's really needed. So if you're interested in training, if you're interested in going, you got to get the CDC training. Got to. Or else you'll be on CNN. And find somebody who's working on site to work with. Do not go on your own. And there's actually USAID has a website I listed here to volunteer and sign up with these. This is basically one-stop shopping, funnel everybody into the voluntary organizations. Right now, they're only looking for people who can do physicians, nurses, respiratory therapists, plus minus, laboratory work, because they need people to run the labs for all this stuff. And then get your hospital prepared, which Thank you.
Thank you very much, George. That was great. Very sobering, but nonetheless very important. And you asked the question, is your hospital prepared? And we have the perfect person to answer that question. What will happen if someone comes into the UCI Medical Center with a suspected case of Ebola? Well, we have for you the person to answer that question. We have Dr. Shruti Gohill, who is Associate Medical Director for Epidemiology and Infection Control at UC Irvine School of Medicine. He's board certified in internal medicine and infectious disease. And he has her MD from Tufts University, and she did a fellowship in infectious diseases at Albert Einstein College. You need to get right up on.
All right, sure will. Okay, everybody. Hopefully you can hear me. Sure. Okay. All right. Well, luckily this slide here is, you've seen this map now, I think I counted, this is the 4th time. So good thing this slide isn't working well as opposed to the other one. So the one point I wanted to make, Dr. Rutherford gave a wonderful summary about the statistics here in the United States, and a couple points I wanted to make. You can't read it so well, but if you look at the number of healthcare worker cases we have had, excuse me, oh no, look at that. How do I go back up there? Oh, good. Okay. All right. If you look at the number of healthcare worker cases, we've had 2 healthcare worker cases from the patient in Texas with Thomas Duncan. And 2 amongst the people who cared, the healthcare workers who cared for that patient, the initial number being those who had very close contact, 16%. If you take that denominator and span it out further with all healthcare workers involved in the care of the patient, it actually becomes 4%. And this is at a hospital that did not have wasn't expecting Ebola, that did not have all of the currently recommended CDC guidance in place. Okay, so that's one point I want to make. The other is that, the symptomatic patient who was sent home from Texas, Mr. Duncan, was symptomatic. He was symptomatic for 4 whole days with people in close contact within the apartment. And we're now well past 21 days after they were all exposed and none of them became ill. Okay, speaks to the issue, the fundamental issue of this thing being highly infectious, but not so much contagious. Okay, it's a small distinction but it's a very important one. Okay, so preparedness in the United States, there are 4 biocontainment units nationally. Biocontainment unit designation is a very important designation. These units are specifically equipped to care for Ebola patients, right? They have personnel that have been trained for decades. They have equipment, specialized equipment. They have processes and protocols. They know how to handle these patients. They've been drilling, if you look at the patients that they have taken care of over the last several decades with this outbreak and the others, we've had no conversions, right? No Ebola transmissions in these biocontainment units. So the importance there is to note that it can be done. We can do this, okay? We can do these in the hospitals. So now, after Texas happened, of course, we've got hospitals without specialized units, right? That are being asked to suddenly upgrade all of our protocols for infection prevention, having to do specifically with the transmission of Ebola virus. And hospitals are at various stages of preparedness. This is an unprecedented outbreak, and in these unprecedented times, the CDC has released evolving guidance on what hospitals are supposed to do. It will continue, I'm sure, to evolve. Particularly, for example, we're waiting for guidance on how to handle infection control issues in the outpatient facility. So there are centers being designated nationwide. We've got several in New York, some in the Midwest, and of course now in California. So a word on healthcare worker transmission. The number of healthcare workers, the last I looked, of course this number changes all the time, the number of healthcare workers acquiring Ebola worldwide, I told you about US statistics, but this particular statistic worldwide is 425, the number who have died 236. Now, many, if not most of these healthcare workers were workers in endemic areas who did not have access to adequate personal protective equipment or adequate infection prevention control protocols. This is very important to note. Despite the media and the hysteria that is somewhat understandable when you're looking at some of these statistics and what's happening out there in West Africa, it's very important to note that, that this is the context of healthcare worker transmission. These are the numbers that we know. We don't really know the acquisition rates in industrialized nations. Well, healthcare workers face specific challenges, right? We have potential exposure to large volume of bodily fluids, close and extended patient contact time, And of course, invasive procedures, right? The exposure is heightened by potential invasive exposures. And Dr. Rutherford mentioned the aerosol generating procedures in particular, like intubation, pose a particular hazard and has a theoretical risk of airborne transmission. So controlling healthcare worker transmission, is it preventable? It absolutely is preventable. And as I mentioned, the other facilities that have taken care of patients and have known how to do that have done it in a way that has disallowed transmission. It absolutely requires meticulous adherence to infection prevention practices. Right? So personal protective equipment is fully protective. It's not, the concentration on the gear has been really intense in the media, understandably, but it's not what it is that's covering you. It's actually avoiding breach of contaminating yourself when you're trying to remove that gear. In minimizing exposures, of course, limiting the number of personnel, limiting the number of procedures, all of these greatly impact the way in which healthcare workers interact with the patient and how they actually ultimately care for the patient. Hospital isolation precautions, we have many isolation precautions that have been in place for decades. We have standard, contact, droplet, and then with Ebola, we have eye protection that's recommended, and then airborne isolation, the practicalities of that Dr. Rutherford elegantly mentioned. But my point here, actually, with this slide is only one, which is that we know how to, as healthcare workers, use personal protective equipment. Ebola is sort of another level of that, but we know how to garb up with some of the basic principles involved in contact and droplet protection, so that at least the concepts are there, the mechanisms are there. We just have to upgrade and upscale and train. So what do I mean by personal protective equipment? So again, CDC guidance has been evolving, and as near as just 1 week ago, they released updated inpatient guidance for personal protective equipment. And the overall sort of notion was no skin should be exposed. We have here, this is a picture actually of what is being used in New York right now. You can see an N95 respirator or powered air purifying respirator, hair cap, face shield, water-resistant mid-calf shoe covers, water-resistant gown and suit. This one happens to be a surgical one. Again, a garb that we use for surgery. And we've got double gloves, top long gloves secured over sleeves, and a hood to cover the neck area. So avoiding exposures is the key. PPE is fully protective when used correctly. The acquisition risk is highest when you're removing contaminated personal protective equipment. And the key principles to avoiding a breach between what's on you and when you take that off is really in the coaching. So as Dr. Rutherford mentioned, in the international community, they practice very much the issue of donning and doffing your PPE. And here as well, putting on, so donning your PPE in the correct sequence. You got to put it on right, so when you get it off, you can get it off in the right sequence, right? Taking it off, and that's what we call doffing. And then we've got 24/7 highly trained observers for every step of donning and doffing. So there's one sort of what we call a safety officer. This is what's recommended by the CDC, to watch you, and they have eyes for nobody else but this one event happening in front of them as they put on their personal protective equipment, and one separate officer watching you as you take everything off, watching for any breaches, right? We've also had guidance for buddy systems for care. In other words, a nurse who would go in to take care of a patient wouldn't do this in a vacuum, wouldn't do it by themselves. There would be another nurse assigned to help retrieve things that they may need, to help out if there's something that happens in the room. This extends to other types of services like the environmental care service, people who are cleaning up after a patient, as well as respiratory therapy, for example. And then really instilling the fundamental sort of belief in personal protective equipment. If you were to get material on you that is potentially contaminated, You have to stay very calm in your mind, and you know that the stuff that's on you is there to protect you, that it is protecting you, and then sort of concentrating in a very stepwise, deliberate fashion to get that material off of you. I think this is the key issue when you're rolling out education on PPE in a hospital. Aggressive education and aggressive training. So it's not so much the PPE, it's not so much the gear, it's the education and the training. So Ebola preparedness reaches far beyond the gear. Every detail of a patient's interaction with a healthcare facility must be accounted for. We've got aggressive screening for patients at risk at every point of entry into the system, from the call center to the transfer center to every single ambulatory clinic that your facility oversees, and then of course your ER. You've got to identify and isolate patients away from public spaces immediately, determine whether a patient meets criteria for a CDC potential case, and then consider logistic details about patient admissions in a pre-specified sort of format. The most we can prepare will be the best sort of medicine to this potential problem. You know, predefine, where is this patient going to go? Exactly how are they going to get there? What are the personnel requirements? What are the equipment requirements needed to safely handle such patients? And the amount of energy, the amount of teamwork that it takes, and the number of different trainees trained at different levels within different departments really have to come together and row together. And the best way you can move forward is if everybody does it, it pulls their weight and does it in time. So it's really been an experience of multidisciplinary engagement. You know, how is a patient going to get their food? How are people going to really clean up the room? Are we going to do chest x-rays? And if we're going to do chest x-rays, are we going to clean the machines? How are we going to clean those machines? How are we going to get them in and out properly? How are we going to alert other people on the medical record? We need information systems to adequately alert all clinicians of what this patient might have so that they follow the proper precautions. What do you do with the linens after a patient has been in them? What do you do with medications? Do you pre-specify the medications and leave some in the room because you're trying to minimize going in and out of the room? How many people do you train? How many nurses do you train? How many physicians do you train? Is security going to need to be involved if the patient elopes? And many other issues. There are external stakeholders. We are blessed with a public health system here in Orange County that I sure have a lot of faith in. You have to absolutely interface with public health. They are our partners here because our borders stop at the hospital and our floors, but right outside that is the jurisdiction of our public health officers. The public water system, Dr. Rutherford mentioned, absolutely the experience of Amory was that the public system said, well, we won't take your water if you're flushed down in Ebola waste. Well, what are we going to do with that? We've been lucky. Our public system here has said we'll go ahead and take that as long as you follow certain protocols. But these things require planning. These things require outreach. Waste management, what are we going to do with all the trash that is generated, whether it's infectious or not? Emergency medical transport. Well, how are we going to make sure that we have people who are willing to transport patients to a facility? How do we manage the community and patient expectations and fears and the media? And so in terms of the clinical management of an Ebola patient, also this requires careful pre-planning. Usually a multidisciplinary team is required in the care of any ICU patient, in particular this one. We've got emergency medicine, infectious disease, GI, nephrology, pharmacy, and laboratory, all working together in a care team to sort of appropriately manage a patient that happens to come in. And key issues include things like IV fluid. Do we have enough IV fluid? fluids. There was, at least at some point, a national shortage on IV fluids. How do we make sure we've got enough for an Ebola patient who might need 10 to 20 liters a day of this stuff? Oral rehydration, do we have enough? Do we keep in stock? What's the PAR level? And then required procedures and many, many, many other things. So the other thing that many people will say who are involved in disaster preparedness is that among all the things that you do, it's the communication that really can sink you if you don't do a good job there. So internally, you've got to communicate to your staff, obviously your clinicians, your MDs and RNs, and other workers, your EVS staff, patients. You know, how do you make sure that patients feel comfortable coming to your hospital because you have an Ebola patient? External people as well, insurers, unions, patients, and of course the media. These are all high important stakeholders. And I just want to put forward to you all that, you know, I won't say it's the same problem, but it's a similar problem. I think you all have touched on, the other speakers have touched on this. It's a similar problem. It's just a different day. We've done this. We've done this again and again and again. We've beat, plague after plague with pain, but done it. This one just needs a different solution. And so I have every faith that this can be squelched, at least in the United States or industrialized nations. We have all the resources to prepare and adequately prevent transmission. And, you know, Joe Poyer, thorough preparation makes its own luck, and I don't think this can be any more case in point.
Thank you, Shruti. Thank you, Shruti. That was great. We have one last speaker. George mentioned the economic impact that this outbreak is going to have in Africa, and we have a speaker who's going to tell us about that. Victoria Fan is a health economist and development economist. She's an assistant professor in the Department of Public Health Sciences at the University of Hawaii at Manoa. And she's a health economist and research fellow also at the Center for Global Development in Washington, D.C. She has her doctorate in health economics from Harvard School of Public Health. And after Victoria's done, we'll have the entire panel up here to answer your questions. So without further ado, here's Victoria.
Thank you very much, Andrew. Pleasure to be here. It's been a long evening, and such tremendous speakers and a distinguished panel. So I've been asked to speak about the economics of Ebola, and I'll just quickly go through a couple of points. First is give you some development context, how poor these countries are. I'm going to move forward with making the economic case for Ebola control in these countries, and I'm going to give you a policy sampler of what we can do to do next. So, very quickly, the development context in these three countries, which we've already seen the maps for, they're really small. They're smaller than even greater LA. And they're also really fragile. They've just, in the case of Liberia and Sierra Leone, they're just emerging from conflict. Long civil wars, hundreds and thousands of people killed, and historically among the largest declines in GDP ever seen. So in Liberia, 91% decline in GDP and 42% in Sierra Leone. And their peace is still very fragile, just a little bit more than a decade long. And not only have they gone through these civil wars, they're among the world's poorest countries in terms of GDP per capita. So we know in the United States, mean average per capita income is about $52,000, but in these countries, it's just a few $100s per person per year. So for every American salary, we've got about 141 Liberians. Or to put it differently, the weekly U.S. GDP per capita is $1,000. That's still, just on a weekly level, still much more than what these people earn on a yearly basis. But there is some hope. These African countries are growing quickly economically. In Liberia, Sierra Leone, we're seeing GDP growth rates of 10, 15%. And in the neighboring West African countries as well, they're all growing very quickly. But because of these low resources in general, that also translates to very few resources for healthcare. So in Guinea, Sierra Leone, Liberia, we're just talking about a few bucks per person per year spent by these governments for healthcare. I mean, $5 for the whole for that person for the whole year. I mean, what can you really buy with that? In the countries in Nigeria and Senegal, where we've seen pretty good control of Ebola, they've just been declared Ebola free. In these two countries, they're even twice or even 3 times that of the poorest countries in Guinea in terms of health spending. And just as a comparison, the PPE equipment that we've heard about so much is $90. I mean, what can you really buy with just $5 per person? And even just compared to their GDP per income, this is what we mean when we say that these are severely resource-constrained economies, and that there's really a compelling case for international aid to support. So what is this economic case for Ebola control? So just very generally, we can think through some of the economic impacts of illness in terms of the impacts on ill families, individuals who fall ill and their families. There are direct effects in terms of the costs of seeking medical treatment. There's also indirect effects. Once you fall ill, you can't go to work, you lose your income as a result of that. You may also be a recipient of stigma and discrimination that leads to job loss. And of course, in these countries, it's compounded by severely weak health systems, where these health systems are being diverted to fight Ebola, and with already limited capacity to address their usual illnesses, as others have mentioned already. And of course, there's also macroeconomic effects on the firms and the sectors and the economy at large, partly from what my colleague Mead Over at the Center for Global Development has called aversion behavior, where you have, out of fear, irrational fears, healthy individuals are self-isolating themselves, and that has broader effects on the economy. And so just to provide you kind of give you a sense of some of the channels of economic impacts, you've got the direct and indirect effects up there, as well as the behavioral effects from aversion behavior. And that translates through impacts through many sectors. Agriculture is the main source of production in these countries, mining as well, and it affects transportation, services, manufacturing, private sector, public sector. And ultimately, we're expecting reductions in food supply, food shortages, as Professor Rutherford mentioned, as well as reductions in incomes, and ultimately increased poverty in what is already a very poor place, poor places. So recently, the World Bank came out with a report a few weeks ago estimating the economic impacts of Ebola in these countries. And my colleague Mead Over at the Center for Global Development was one of the only non-World Bank economists working there. The rest were country economists in West Africa. And just to give you a summary, they find that an estimate of about $33 billion lost in 2014, 2015 in West Africa, where it's about 1/3 of economic growth. And the epidemic is still growing, so this may actually still be an underestimate. And they conducted low and high scenarios, but it seems like the low scenario is already implausible. So just to give you a sense here, in West Africa, these a dozen or so countries in West Africa were expecting in 2014 and 2015 as many as $25 billion of lost GDP, or about 2 percentage points of lost economic growth. And in these 3 countries in particular, the red here is in their high Ebola case, which is still actually more conservative than the CDC case of, I think it was 1 million cases, 1.4 million cases. I think in their high scenario, it's about 200,000 cases. In this scenario, it's still about $800 million of lost GDP in just these 3 countries. We're not even talking about the economic losses to Western countries, for example. And so in Liberia, it's already certain that we're going to see increased poverty rates. You can see here, so this is, the axis is a percentage of people living in poverty. So, as many as half of the population are living in poverty, and this is a very, very strict definition of poverty. We're talking about like $1.25 per person per day. This is, to go even below that is what we're seeing, expecting to see in 24 and 2015. So this is really about, the cost of inaction. Why should we be waiting until it costs us even more? And the $33 billion may not seem so catastrophic, but can potentially get even worse if we don't do something. And so from the perspective of West Africa, averting these large expected losses is a really good investment, especially if it's cheaper than the costs. So Benjamin Franklin said that an ounce of prevention, a pound of cure. And by comparison, the WHO has called for about $1 billion, which is actually just a fraction compared to what these countries are going to lose. And the result would be a tremendous global public good with benefits not only to West African countries, but also to US and other high-income countries. So I'm just going to give you a quick sampler of just some policies moving forward from an economic lens. The first question that I had was, as Professor Rutherford mentioned, is this current scale of intervention sufficient? And it seems probably it's probably not. Second question is, in the medium term, is this system for international cooperation for global health broken? And the third is about this R&D issue of finding vaccines for Ebola. So the first is about this current scale of intervention and the public health mantra of early detection, early response. I think we've seen that to some extent in Nigeria and Senegal. They found the 19 cases through, I think it says 18,000, but I think it's actually more than that, 20,000. It's also incorrect, it should be 20,000 interviews of potential cases. And so it's incredibly high cost effort in the front, but you avert many potential losses later on. And in the case of Liberia, the US has deployed 17 of these Ebola treatment units with 100 beds. That's a few thousand, but it's likely that we're still not at the scale of intervention that we need. We probably need a few more thousand beds at least. And my colleague at NYU, Karen Greppen, has argued that we, as Professor Rutherford was saying, that we really do need some alternative and scalable models. It's really a matter of experimentation. And so moving forward, is this international system for global health broken? And so for those of you who are new to this global health space, this graph shows you how global health funding has grown over the past 2 decades or so, from 1990, from a couple of $1 billion up to $28 billion. But this little blue block there is the WHO. And you can see back in 1990, there were only a handful of other global health funders. But moving on towards the current day, they're just one of a handful of players. And WHO's budget has not increased over time. So what we're seeing is that there's a lot more donors for global health, essentially crowding out these bilateral contributions to the WHO. And it's partly, I think, there's some lack of confidence by these bilateral donors in the WHO and its governing structure. It's got a unique decentralized structure. And as a result, we see that the WHO has a very paltry budget for outbreak response, smaller than the CDC's, and even paltrier for health system strengthening. And so we really do need to think through how we're going to reform the WHO and how to reform this broader structure of global health governance. And then finally, thinking through, what about research and development for finding a vaccine or a cure? And so this New Yorker cartoon says, it's fine to discover cures, but remember, chronic conditions are our bread and butter. And the economics of R&D for diseases of poor countries has been well established. It's really expensive to develop a new vaccine or drug. It's about $1 billion. And it's also well known that the sales market is just too small for big pharma to justify the large commercial investment for new products. So what solutions do we have? Well, again, this is another work from my colleague at the Center for Global Development, Owen Barter, who's developed this idea called the Advanced Market Commitment, or essentially prizes for discovering these new vaccines. So what it does is that these donors provide a binding commitment to pay for a desired vaccine or drug if and only when it's available. And so thank you very much for this opportunity, and I'm happy to answer more questions.
I'll use the moderator's prerogative to start by asking the first question while the mics are organized. And that is, we've heard, George, from you about the situation in West Africa, and we've heard from Shruti about how prepared we are here in the States. But the question came up over the weekend about how to sort of a bridge between the two geographies, and that is, what do we do with people who have been working in West Africa and then return to the United States? So I'll let you answer that, George.
Sure. Well, CDC's guidance, as Shruti says, is changing daily on this, and it changed again today, and I haven't looked it up yet, but I think what's happened. So there are two types of people that are coming back from West Africa. I mean, there are lots of types, but just sort of generally, there are people who are trying to get out of Dodge, and think Boccaccio's Decameron during the Black Plague of Florence, right? They're going away for like an extended holiday someplace far away, and there are these healthcare workers who've really been squarely in the middle of all of it and are really at substantial risk of having been exposed. What we're doing now is everybody who's coming from one of those three countries, again, Guinea-Conakry, Liberia, and Sierra Leone, are funneled through 5 airports in the United States, which are Kennedy, Newark, Dulles, Atlanta Hartsfield, Chicago O'Hare. And there are CDC officers there who take I don't know, you know, I can't begin to tell you, you know, sort of excruciatingly complicated histories about where they've been, what they've been doing, what kinds of exposures they have. And they have the ability, this is one of the few, most public health law in the United States, state law, but this is where federal law actually comes in. They have the unquestioned ability to be able to do whatever they want to with them, including quarantining them. But what's really happening now is unless they're febrile, unless they're sick, they get passed off, this is I think the newer version, is they're getting passed off to the state and local health departments and are being asked to stay in home quarantine for 21 days. Is that right? That's right. That's right. So, and before it was a little bit, looser, and I think that's probably not unreasonable. So that's the kind of cost of action. You can also potentially do your quarantine on site, and I know at least MSF, Médecins Sans Frontières, as they're rotating their clinicians out, their clinical personnel out, have them do 3 weeks of quarantine doing administrative and kind of public healthy jobs on site, which I think is sort of a nice compromise because they have the care facilities there. Of these fancy Ebola treatment units, the first one that's being constructed is for healthcare workers, by the way. So if they do get sick, there's some, you know, really sort of state-of-the-art on-the-ground stuff.
Great, thank you. Do we have audience questions? Can we get a mic to? No, over here first. Sorry, you're next. Thank you.
So if you have a healthcare facility that can treat, say, 100 patients, how many healthcare workers are needed for a facility of that size? 400.
There's an exact number for this, and you can have a few more, but that's what sort of staffing looks like. It's basically 4 to 1, 24-hour staffing. You knew that, right?
Thank you. Excellent discussion, subject matter, and all of the speakers very, very informative. Doctors Rutherford and Gohill commented on intubation and invasive procedures that are used frequently in U.S. healthcare situations. And there were some comments about, that I was following up on from other sources, that these types of procedures are less used in other countries. Can you comment on whether we should be doing those types of procedures? How helpful is it? And do other countries in West Africa also do them?
Sure. This is all about me. Yes, they absolutely do them. They absolutely have the capacity. Are they going to do them for Ebola patients? No, not right now. Probably the most important procedure you could do for these patients is to put a central line, a subclavian line in. Now talk about blood and exposure and exposing your, like 3 surgeons that are left in Liberia. They're probably not going to do that. So they'll do most of the rehydration through peripheral IVs. They'll give them supplementary oxygen, but they're not going to do big, and they're not going to dialyze anybody. One of these patients got dialyzed. They're not going to do anything. You know, that's really stretching the far, far edge of the capacity. But you know, the giving large volumes. I mean, Shruti said 20 liters a day, which strikes me as about right. You know, huge volumes plus blood products. They're going to be giving those through peripheral IVs because people aren't going to want to start a 14 gauges like this big. That's probably more like 12. But they're not going to put in some large bore subclavian catheter where you can just sort of pour this stuff in. It's all going to be done through peripheral IVs. You know, it's a tough call. If you have peripheral IVs, they're going to clot off. They're going to be positional. There are going to be problems with them. And you probably would have fewer sticks and less exposure to do central lines. But these are all sorts of things that are being weighed. What I can tell you is that MSF and Partners in Health especially, are very outspoken about the needs for providing Western-style care, which will mean central lines and those kinds of things. I think the problem is going to lie in these Ebola care units where they really aren't going to do procedures at all. And they probably won't start IVs, and they probably won't draw blood. And they'll try and rehydrate people with oral rehydration solution like they have cholera. And unfortunately, this isn't cholera, and they're going to need I don't know that that's going to work. So if the Ebola care units can't save patients, then people aren't going to use them. They're going to be back at the houses. It's just going to be a big mess. So we're hoping that we can sort of push some technology out to those, but we'll have to see how it goes.
I can just comment on the U.S. portion of that just real quick. In terms of intubation here, the idea would be to do as much as you can in a controlled environment in advance, preemptively as much as possible, and with the kind of gear that we have and the kind of facility and resources we can dedicate to a single patient as opposed to hundreds, thousands, it would allow for the safe intubation of a patient in our facilities. Although this is an area of controversy, I'm sure.
So we have a question here in the front, and then on the left.
How many major epidemics have there been over the past 30 years, and what are the major differences in how you handle them and what you expect to learn from these epidemics, from the thousands of people that died?
That's a question for Dr.
There have been multiple. There have been lots of major epidemics. HIV has really been in the last 30 years, at least as it's been recognized. 34 million deaths from HIV, 34 million living cases, 20 million plus deaths. There have probably been, I would say, if you're talking about large, multinational, large spread outbreaks, there have probably been a good 100. Now, they're all transmitted differently, and that's why the transmission part's so important. So HIV is obviously primarily transmitted sexually. Chikungunya virus, which is or dengue, are transmitted by mosquitoes. So that's a whole other set of parameters you have to deal with. This is far and away the largest hemorrhagic, well, except for dengue, which has the mosquitoes. This is far and away the largest hemorrhagic fever outbreak in history, at least that we know of. And so there's not a lot that we've learned in the last 100 years, last say 30 years, except for some of the other smaller Ebola outbreaks, right? Not heavily studied. I think, as Mike says, this is not a big, the Department of Defense likes to fund this stuff, but it's not a big NIH target. So I don't know that we have that much, we've gone to school that much on the last 30 years of stuff. Although we have for the media, that's clear. Mike, do you want to?
I would just add to that with Ebola and Marburg collectively together since 1976, there have been about 30 outbreaks. Most of those outbreaks have not exceeded 100 patients, and that's because they occur in villages. I should say one more thing for the audience, and that George, I think, has touched on this as well. When you look at the exposure of family members, the morbidity and mortality in family members is disproportionately high among women over men. It's estimated in some of these outbreaks that 80% of the fatalities were in women, and the reason for that is the women are doing all of the ritual cleansing for burial and taking care of the sick patients, taking care of the sick children, and so they're placed at much higher risk. And so when you think about a family that relies on women to do so much of the work to maintain the family, it's really a devastating situation. There was a very interesting story in this morning's New York Times about this organization of Ebola survivors that is taking over the responsibility for care for the orphans who've been created by this infection. And that's the kind of thing we want to look for. It's really taking the responsibility locally rather than relying on outside agencies.
I'm interested in the interrelationship between the viral infection and the life of the patient with the virus and the development of immunity. I have sort of a simplistic thinking that the first initial infections, the virus tends to want to go to the gastrointestinal tract, but later perhaps the viral load builds up and affects all tissues to some greater or lesser degree. And I'm not sure just how the immune system can help and why it helps in some people and not in others.
The initial target of the infection is the immune system, and it's the innate immune system. If you consider the phagocytic cells, the macrophage, the cells that would normally attack any kind of an object or any kind of an infection that infects your body, The reason some people survive and some people don't may have to do with dose, but it may also have to do with, again, with the possible low levels of background antibody in the population. And we really don't know what that number is. Again, we know very little about the background antibody to Ebola, to Lassa, to many other infections. I would disagree with one thing that George said, and that is that probably the largest outbreaks of hemorrhagic fever we've seen were yellow fever. Yeah. Which struck this country up until 1903.
You said last 30 years, come on.
In the last 30 years, that's right, in the last 30 years. But remember that when we think of this, that yellow fever almost shut down the government of the United States in 1787. Yeah. Because yellow fever struck Philadelphia and killed almost 10,000 people in Philadelphia. And so this is not beyond the scope of our experience as a country.
Several questions over here, so the people with the mic, and then we'll get to you next. So Shelley first, and thank you.
First, I'd like to thank you, Andrew, and the panelists for a terrific discussion, but I'd like to ask a long-term question. The knock on global health for many years has been that the Western countries helicopter in and take off. And with this investment, granted not enough, in all these treatment centers, is there any possibility of using this moment to turn them into more long-term kinds of projects? For example, George, you mentioned malaria that's not getting treated right now, a huge problem all over. Is there any thinking about the possibility of sustaining these units for vaccine trials, for antibody collection, for surveillance, sending medical students over, lots of people that want to do global health, and so forth?
The example has been made of the way Firestone Rubber, which has extensive plantations in these countries, has been handling the infection on their own. They decided not to wait for outside people, but the company itself set up hospitals, clinics, treatment centers, and really set up first-class medical care for their employees. And they employ about 150,000 people, so it's not insignificant. And their success rate is much, much higher than the background in the community.
But yeah, I mean, the $64,000 question here is how do you parlay this up into a lasting improvements for the healthcare system? And these units are made out of plastic; they're not going to last.
There was a question over. Yes, yeah. Go ahead.
Okay. I was wondering if you guys could clarify something. So cooking the bat meat, so we heard that the bush meat is likely the cause. If cooking the bat meat doesn't kill the virus, then how is it that burning the waste in this country is going to kill the virus? Is it a temperature thing, or?
Cooking the bat meat likely does kill the virus, but you have to prepare it.
Okay,
you know, you
so
saw
you
the
think
picture
it's
of
coming
the
through
man with
preparation.
the big rodent, and then they split it open and they fillet it out and they smoke it. So in the process of preparation, this is exactly the same experience that we found with SARS in the live animal markets in Asia. The fact that you choose a live chicken and then they take it in back and they sacrifice it for you and clean it and bring it out. And those are the people that are exposed.
Okay.
And remember, with a case like Ebola, it only takes one
Right.
case, to begin an epidemic.
Yeah. Thank you.
Can we? Great. Right over there.
Thank you. It's been very informative. Mike, you said you talked about potential vaccines and ones that have been tested. Assuming one could ramp up and produce enough doses, how would you introduce a vaccine into West Africa now?
There are 2 candidate vaccines right now that are being discussed. One is being promoted by the NIH, by Tony Fauci, and it's an adenovirus vaccine. And in my opinion, and this is my opinion, this is not policy or anything, the fault with that vaccine that it requires multiple doses. And the problem you have in a population like this is people are extremely fluid in terms of their activities, in terms of their availability. And it's not like everyone carries a driver's license. And so you need to get people to come in for their first shot and then to come back in at a prescribed time for their second shot in order to be fully immune. The second vaccine type is a recombinant vesicular stomatitis virus that carries the Ebola spike protein, replacing the VSV spike protein. And this virus grows to very high titers in vitro, so you can produce a lot of it very quickly, and it only requires 1 dose because it's a live attenuated vaccine. So that's the second one that was developed by Heinz Feldman and Thomas Geisbert at the Department of the Army and the NIH Rocky Mountain Labs in Canada Health, and is now just this week has been announced that it's going to be put into operation again. So I would favor that second vaccine because number one, we know that a live attenuated vaccine will induce a stronger response, and secondly, it requires only 1 dose. So, you know, you can bring people into a mass vaccine campaign and then turn them loose again with some surety that they will have been vaccinated. There is possible side effects, and that's the reason that we need to really do clinical trials. But that would be the quickest and certainly most adaptable vaccine right now. The danger is that the virus may evolve away from that antibody pressure. I would definitely vaccinate healthcare workers.
So the woman in the far back there, you had your hand up. Can you please raise your hand between the questions so we know the people with the mics know where to go between? Thank you very much.
Thank you. Similar to the discussion on vaccines, someone mentioned the New Yorker article about the work being done at Harvard, which I read, and it seemed to me pretty far back in the article there was a mention of ZMapp, a treatment that there were perhaps 4 doses of, but 2 of them did make it to treat 2 individuals, and they did seem to have a miraculous recovery. Is that media hype, or is this real?
George? 5 people have gotten it, 3 have died. Okay,
yeah.
So this is what they don't tell you. Yeah. This is basically how we treated infectious diseases in the 1930s. In the 1930s, when you got an infection, you hoped that it coalesced so you could get a surgeon in to drain it or cut it out. Or we used serum therapy, where we gave people antibodies. Now, we still use serum therapy for a few things, but this is basically, ZMapp is a fancy form of serum therapy. They're basically growing antibodies, they're primate antibodies, to 4 proteins. But the problem is that the production system is tobacco plants. This is the land of bioengineering. Tobacco plants don't grow fast enough to crank out these antibodies. There's lots of discussions going on now about putting this into a yeast system, which becomes like brewing beer. You can create large volumes of these antibodies and get doses out. But at the end of the day, it's serum therapy. It's 1930s serum therapy. So
we have time for just a few more questions. So the 2 of you in this bank of seats had your hands up. So okay, and we'll do some over here.
A quick question. Do we know how long the virus can survive outside the body? And could it be put in, like you were mentioning earlier, in the wastewater? Could that go just run through in the water treatment and infect other people, or it's impossible?
Go ahead, Shruti.
So very important, very good question. So, so in terms of going through the wastewater and infecting other individuals, no, particularly in industrialized nations, what we deal with, by the time it hits the system and goes through our disinfection system, there are standard disinfection protocols that are followed that kill the virus. Actually, the virus is pretty wimpy. If you take it across all the other types of viruses, it dies fairly easy. And to get at your question of how long can it survive outside of the body, it needs fluid to survive, some sort of medium to survive. And what's noteworthy is that in Emory, I think it was Emory that did the study where they had taken cultures of the environment and tried to find evidence of, actually it was PCR, to find evidence of the virus. They found none anywhere. Of course, they were cleaning it significantly. But I think that epidemiologically, you guys can speak to it much better than me, but in the worldwide setting, if it were true that it could survive outside the body in inanimate surfaces for prolonged periods of time in an infectable sort of format, then I think this would be much worse than it is.
Hi, I know you mentioned that this virus is not airborne transmission. However, it does have the potential to be aerosolized, such as coughing, sneezing, laughing, and vomit. So my question is for healthcare workers, why is it when you see on television, or even the lab workers that work at the biosafety level 4 facilities, since this is a biosafety level 4 virus, why is that we're not wearing positive pressure suits and having the hazmat level A suits and whatnot?
Talk to it, I think. I think it's a very important question.
I have another comment. And then in the event that they present into ED and they're symptomatic and they come along with large family members, what do we do with those family members too? Because I myself, I work at UCI Medical Center. I'm one of the RNs there. So all of the UC Medical Centers statewide are going to be they're chosen to be the Ebola receiving hospitals and whatnot. So what are we doing for preparing and for running drills? And is UCOP going to kind of oversee if we're all getting the same training and all same PPEs?
And lots of questions embedded in there. I'll try to take it one by one. So with regard to this issue about airborne transmission and procedures and aerosolization, to my understanding, this is a theoretical risk. It's not something that we expect. The reason, the dissonance between what you see on TV, these sort of spacesuit type of things, and of course our own PPE coverage from head to toe, the dissonance between that and then the family who's sitting with the symptomatic patient for 4 days, actively nauseous, vomiting, and having diarrhea and not getting sick, that dissonance needs to be, that needs to be bridged. And it goes to the heart of your question right there. And so, as Dr. Rutherford had mentioned before, it's really an issue of practicality, of comfortability of our healthcare workers who go in there and have to take care of the patient. And in the span of time that you would get aerosolization from something like Ebola, the proper mechanisms that you would recommend with a respirator and or a PAPR, not and, but an or. We do tuberculosis, bronchoscopy on tuberculosis patients, right? It's far more high risk procedure.
So to answer your question, UCOP, by the way, is the University of California Office of the President, so just in case you got lost in our lingo. So on Friday, Governor Brown declared that the 5 UC academic medical centers, which are in San Diego, Irvine, Los Angeles, Davis, and San Francisco, would be, were going to be the first ports of entry for Ebola patients. They didn't quite say it that way, but that was the idea, that they would be that they were the frontline facilities. They're going to be the frontline facilities for a week, and then it's expected that Kaiser and Sutter and everybody else is going to catch up. So it was a kind of a temporary stopgap announcement. UCOP and the, sorry, I'm trying to look at you through the, you look an awful lot like the podium from here. The UCOP through the office of the, there's a vice president for medical affairs. They are overseeing the, just trying to look. They are overseeing the, trying to standardize what's going on at the medical centers. There is local planning, obviously, but yeah, there is some oversight of that. Is it as tight as it should be? I kind of think it probably is. This is a high enough stakes game that they're going to try and assure comparability across the 5 academic medical centers. Now, when I say 5 academic medical centers, so at UCSF, where there are 4 different hospitals with completely different managements. So San Francisco General is one, the UC Medical Center, which actually is 2 separate hospitals, the VA, and then Children's Hospital Oakland, which has just kind of come into the family. There are 4 separate plans for those, but it's the UC Medical Center, the UCSF Medical Center, that's the one we're talking about. The others have their contingency plans in case somebody walks through the door, but the idea is that they're going to get concentrated down. Now, this kind of begs the larger question for CDC, which is, if we have 11 biocontainment beds, what are we doing screwing around letting these people be at Texas Presbyterian Hospital? You know, whose idea was that? And I think that they need to take a big step back and think about this. Now, obviously, if we're going to talk about hundreds of patients, and I think we'll probably talk about tens eventually, it's just going to happen. There's going to be leakage from these countries. There's so much disease there, which is why it's so important to attack it there and not kind of wait for it to come here and, you know, play guess who's got Ebola. It's, you know, the response, I think the biocontainment facilities, you know, which are in Bethesda and Atlanta and Nebraska and inexplicably in Missoula, Montana, you know, with 11 beds, that's probably about the capacity we need. And, you know, I think there's a real question, a policy question floating around, which is whether they should transport all the patients there. Now, before you get the engines revved up and, you know, get it all set over there, you're going to be stuck with these guys for a couple of days. So yeah, you need to have the preparedness. And I think we probably will concentrate down regionally and then really think about moving them to these really high-grade facilities for the course of their illness. Again, within current numbers, we could pull that off.
Thanks, George. I'm afraid we're out of time. It's already 8:10, and we're supposed to go till 8. I know there's a lot of interest in this topic. There is some information up on the URL that's on the screen, and that will be updated as time goes on. Let's thank our panelists once again.